He's a security researcher. I just saw the topic and I was like, woo, okay, you're coming to Hawaii. And then also Jonathan said that you gave this talk at Hakito, right? And he said you got to check it out. So give him a big Hawaii welcome, everybody.
Thank you. So I'm working at British Telecom and I would like to introduce you this topic about contactless credit cards, which I've worked in since last December. So first, who am I? I'm doing penetration testing, security training and security research at British Telecom. I'm working in Paris, France. My main interest is protocol security. That is to say authentication, cryptography, information leakage, or zero knowledge proof. And I'm also interested in numbers theory. All that relates to cryptography, like integer factorization, primality testing, elliptic curves, and so on. So first, what is contactless payments? Contactless payments is everyday payment you can do with your card without any need to insert the card in the terminal or type your PIN. So this is a way to do easy payments. Okay? And there are two major systems, one by Visa and the other by MasterCard. They are called PayWave and PayPass. They are designed for small payments. That is to say, you can only pay small amounts like 20 or 25 euros every time. And only do that 4 or 6 times in a row. After you will need to insert your card again and to type your PIN in order to have additional contactless payments. So this is for security reasons, of course. There are 10 million NFC-enabled cards in the US, at least, and 500,000 in France. So how to recognize an NFC-enabled card? So please, guys, have a look in your wallets. If you have this kind of logo on the top of your card, so the Wave logo, it can be black or white. This way you can recognize if your card is NFC enabled. So what are the goals? It is for faster, simpler and easier payments according to vendors. MasterCard Canada has studied the fact and told that there are about 25% more payments using this kind of card because it's easier, so people pay more and more with this kind of card. And this is completely interoperable, and that means merchants only need one reader to accept both systems. So MasterCard and Visa. These are based on a very famous standard, which is called EMV. That stands for European MasterCard and Visa. So all data storage and security is made on this protocol. This is the same protocol than in normal cards, that is to say, not contactless. And protocol commands and card storage layouts is made on ISO 7816, like many other cards, not only payment cards. What is EMV? So EMV stands that the card layout, the card storage layout, is like a real file system, so with a root directory, which is called MF. There are folders, which are called DF, and there are files, which are called EF. All of them are identified by 2 bytes, have an ID made of 2 bytes, according to ISO 7816. And the data, which is in every file, is encoded in a BER TLV. So a TLV is a triplet with the type of the data, the length, and the value. So every data, in fact, is a record made of a triplet, type, length, value. And there is an online decoder, so it's quite useful to make it automatically, because it's automatically, but to do it by hand on emvlab.org. What is ISO 7816? So this is the standard for all comments you can send to the card. Requests are made of 1 byte for the class of the request. So the class of the request is very often the application you are talking to on the card. Because on cards there can be several applications. So first byte of the request will be the class. This is to say the application you are talking to on the card. Second byte will be the instruction byte. That is to say, what do you want to do with the card? So you can read a record, for example, you can write a record. You can request property for a given file. Then there are 2 parameters of 1 byte long each other. You have 1 byte for data length. That is to say, if you have to send data to the card, you will indicate how much data you send. You have the data field for the data itself. And the last byte will be the length of expected response, because you have to send to the card how much data you are expected before receiving the answer. Otherwise, there will be an error. And the answer is easier, it's pretty much easier in its structure. The answer is just a data field and 2 bytes of error codes that are called SW1 and SW2. 1 byte each. So this way you can talk to the card in contact mode. This is mainly the contact mode protocol. So the idea was to study different kinds of cards you can find, different kinds of similar cards. And in France you have a very famous transportation card, which is called the French Navigo Contactless Transportation Card. It's also used ISO 7816. But there are no personal data on card. There is only a card ID, so it's quite anonymous. It uses good encryption, good authentication, and even digital signature. So it's quite secure, no personal data, and very good security with ISO 7816. You have already heard of RFID passports also. They use encryption, and they use combined reading to avoid rogue access. That is to say, you can read the passport remotely using the contactless protocol, but you will get encrypted data. And the key to decrypt the data is somehow written on the passport itself. So you need an optical reader also to read the key and to decrypt the data. You need a combined reading to do that. So it's quite good security. So my question is, my question was, does RFID cards, credit cards, have the same kind of security? NFC payment card should be at least as secure as transportation card, but this is not the case, unfortunately. So you have nearly military security for transportation card and nearly no security for payment cards. So that's a real shame. So what is exactly NFC? So NFC stands for near-field communication, and there are different names for nearly the same thing. You have RFID, which stands for radio frequency identification, NFC for near-field communication, and NFC is a kind of subset of RFID, so they try to make it more standard and more easier, so they call it NFC. And you have even a French name for that technology, which is CTZ. Basically, they use two kinds of frequencies. You have high frequencies and you have low frequencies. And most common protocol is high frequency. So this is the case for the Navigo transportation card. This is the case for the RFID passports, and this is the case for the NFC payment card also. What's interesting with this kind of protocol, the ISO 14443, which is the most common HF protocol, is that it can be used for tunneling and encapsulation. That is to say, it's not a protocol by itself, but something you can use to tunnel or to encapsulate your command and send them remotely using the contactless technology. So in order to do that, you need to have an NFC reader. So there are different kinds of reader. You have USB readers that are very cheap. So I mainly used this kind of USB drive. So this is a small USB drive with NFC. It's only 30 or 40 euros. You can find it on eBay very easily. This is a very cheap dongle. You have a flat reader also. You can find it very easily. And now most phones have NFC enabled. So if you buy a recent Android phone, or if you buy the upcoming iPhone 5, you will have NFC. Then you need to have tools in order to prototype or to test the protocol. So first, I had to test the ISO 7816 protocol in order to choose what are the useful commands I will use in contactless mode. So first, I used the contact mode in order to test the card and see what commands are really useful to query the card. So I used the scriptor command to send ISO 7816. So this is a command line application, so you can send live commands and see instantly the answer from the card. You have nearly the same tool for contactless protocol, which is called PN233X International. It's bundled into the libNFC library, so it's an open source library to use NFC. And the final coding of the tool, I will show you, was made also with libNFC because it's very convenient. Start of frame, end of frame, and CRC are automatically computed. So it's only it's very useful. You have to only care about the command itself, and everything else is handled by the library. So what is the available data on the card? So my question was, is everything on the EMV protocol available through the contactless interface? So I can tell you that the cardholder is stored on the card and is available remotely. So you can gather the gender, the first name and the last name of the victim. You can gather the PAN, which is to say the primary account number, the number you have on the top of the card. You can gather the expiry date. You can even gather the magnetic stripe data, because for compatibility reason, the magnetic stripe data is written in the chip itself. And as the chip is connected with an antenna, you can directly read the magnetic stripe data remotely using the protocol. And you have the transaction history with the last payments and withdrawals the user made with his card. You can have from 20 to 120 history data. There are probably all general card information like issuer, public keys, and so on. But I haven't tested that for regulatory reasons. And the last question was, is the CVV available? The CVV is the 3-digit code you have on the other side of the card that is often needed for payments. So the CVV is not stored at all on the card. It's not on the chip, so it's not available remotely via the contactless interface. It's just written down on the card for security reasons. But there is a one-time CVV functionality. So this way you will be able to get a CVV and to make a payment. You just have to ask the card for a valid CVV, and it will compute one-time CVV, and you can send it and use it for payments. So this is kind of a joke. What are possible attacks? You can read the victim's card data and use it on e-commerce websites. It's very easy to remotely read the cardholder name, the PAN, and the expiry date. And this way you will be able to make payments on the internet. CVV is not always mandatory. On many sites, CVV is not asked. And when CVV is asked, it's not mandatory. You can leave the field blank. It works in some case. And even if in the case the CVV is mandatory, you can easily brute force it, because it has only 3 digits, so it's only 1,000 possibility. 1,000 possibilities can be exhausted in 2 minutes with a script, and bank doesn't block CVV trials not to bother the cardholder. Okay? So it's very easy to make a payment with this solid data. You can probably dose the remote card because you can send the PIN wirelessly using the contactless interface. So if you send 3 bad PIN on a row, you will probably block the card. This attack I haven't tested, but you can probably block the card because the functionality is here on the contactless interface. You can create a magnetic stripe dump remotely, and it will be useful in most countries. The chip is not mandatory. That is to say, most countries in Europe and in the US. It will depend on the card, because some cards have not all the magnetic stripe information on it. So you will have only partial information from the magnetic stripe. And last attack is user identification and tracking. As the contactless card does have cardholder information, so gender, first name and last name, you can use this functionality to, for example, track somebody or detect if somebody is in a corridor, for example, and make a bomb explode when some people approach the device. Okay? So this can be used for terrorism. So what is a typical attack sequence? It's quite easy. First, you have to wake up the card, because the card is only passive. So you have to send a command to wake up the card. That is to say, to have the field power on and wake up the card. The command is quite easy with NFC. It's only those 3 bytes you send to the card, and the card will wake up and will listen to other commands you send to it. Second command will be to select the banking application. As we have seen, there can be several applications on the card. You have to select which application you are talking to. And the easiest way to do that is to gather the application ID on a receipt. Every time you buy something or you withdraw something from an ATM, you have a receipt, and it's written on the receipt itself. The application is in blue, the application ID. So this is the more convenient way to have it. So for French carte bleue cards, the application ID ends with 421010. Once you have selected the right banking application, you have to read a specific EMV record, like in contact mode. And this record here will be the magnetic stripe dump. And in the magnetic stripe dumps, you will have all the cardholder information, the PAN, and the expiry date. So this is the more convenient way to gather all information in one time. So what is to be understood is you have to prefix all EMV commands only by a specific header, which is the contactless header in black. The EMV commands are in green, and you have a trailer which is a null byte at the end. So it's very easy to transpose EMV commands to contactless mode. Only a header and a trailer to add. This way you will tunnel, you will encapsulate the command. You can use them wirelessly. Some well-known application IDs for Visa, MasterCard, American Express, and for French carte bleue card. You can find them here. But be careful, according to the application ID you use, EMV record will have different IDs. So you can have an ID for a given application ID, an ID for a given record, which is different if you choose another application ID. So the magnetic stripe dump, for example, will not be the same ID if you choose the Visa debit credit application ID or the American Express. You have to map them accordingly. Let's have a small demo. So this is a small program I've made in C. It's only 100 lines long, so it's very short for a C program. Here's my wallet. And in my wallet, in its side pocket, I have my NFC credit card. So I let it in the pocket. I just have to put my wallet near the reader in order to gather all information. There it is. So for security reasons, I have put stars on the PAN number. But you are able to get the full PAN. That's not a problem. So you can find the cardholder name, gender, first name, last name, the PAN, the expiration date, and the history, the last 20 in this case, history elements with their kinds, if they are payments or if they are withdrawals, with the date and the amount. So, yeah?
I'm just wondering, do those aluminum cases that you carry in actually lock working?
Yeah, we will talk about that. Yeah.
All right.
So this code has been released on Google Code. I will give you the project name later. And especially for Shakacon, I will release an Android application that was the same. So let's go for a demo with an Android phone. So this is an XSS Android phone. I launch the application. I have to refresh the screenshot every time. It's waiting for the card. I put the card near the back of the phone. Demo effect. Okay, let's try it again. Something goes wrong. And this is what appears on the screen. So this is basically the same output. And I will release the source code for the Android application, especially for Shakacon. So first, I will gather credit card number in order to support the hosting for the source code. So what are the attack limitations? The first limitation is the distance. Okay, the standard, the ISO 14443 standard states the reading can be made to 3 or 5 centimeters in practice. But tweaking the device, we can go further, and a lot further, 50 times better, in fact. I've been able to do that to 1.5 meters using a dedicated amplifier and an antenna. And all fits into a backpack. So, I mean, if you are in the transportation, you can read many cards completely tested. So this is active reading. But we can do better and do passive sniffing. That is to say, wait for somebody to pay with his card and just listen, just sniff the wireless protocol. And this time you can go up to 15 meters or probably better with an amplifier and a dedicated antenna. I've been able to do that with only a small talkie-walkie and a telescopic antenna. I have succeeded in reading up to 15 meters. So this is passive sniffing with a small talkie-walkie. So you can see the distinct reader probes, the communication with the credit card in the middle, and probes again. So this is what you receive up to meters away. How to protect? You can take a watchdog. So this is one of the best ways to protect. Or buy some kind of RFID blocking wallet. This is what you are talking about. But it is not convenient because you have to get out your card each time you must pay, and it's not very beautiful. Sorry? And the wallet only stops active reading and not passive reading. Because when you will pay to the merchants, somebody will be able to sniff the communication remotely. So it only blocks active reading when the card is in your pocket, unfortunately. So how security should be with these credit cards? First, contactless accesses should be authenticated to avoid rogue readers. This is the case with the French Navigo transportation card. Contactless protocol should be encrypted to avoid eavesdropping, and session integrity should be ensured to avoid injection, so digital signature or HashMac, for instance. And this already exists. I mean, all all this kind of security already exists. This is the case in the French Navigo card, and have not been used, unfortunately. So the conclusion is EMV is poorly designed for NFC and needs a complete rewrite. And you cannot use the same protocol on contactless cards. It's not made for NFC. There are other kinds of problems, regulatory problems. So there are two issues with this lack of security. First issue is the PCI DSS compliance. The second problem is the personal data protection. So let's talk about PCI DSS. I don't know if you are aware of this kind of regulation, but PCI DSS is a standard for all merchants that accept payments with credit cards. If they are using lots of credit cards by year, they must comply to the PCI DSS standard. So all companies that handle cardholder information must comply to this standard, which is made by Visa and MasterCard to reduce fraud. Okay. And requirement 4 of the standard states that you must encrypt transmission of cardholder data across open public networks. The scope is all wireless technologies. So NFC is one of them. And there is even a procedure in PCI DSS which states select a sample of transactions as they are received and observe transactions as they occur to verify that cardholder data is encrypted during transit. So obviously, this is not the case with the NFC credit cards. So NFC credit cards are not compliant with PCI DSS, and NFC credit cards are made by the same, by Visa and MasterCard, so their card doesn't comply with their own security standards. This is a major fail, okay? An organization can become non-compliant to PCI DSS by accepting contactless payments. This is the consequence. One surprising thing is when you read the FAQ on one of the two vendors, okay? They state that technically the contactless functionality protects cardholder information using very secure dynamic cryptograms. Indeed, it's clear text.
He just followed up with devices. So he just wants the ASI.
And the other issue, regulatory issue, is personal data protection. So as you know, in Europe and in France, there are regulations about personal data protection. And in France, specifically, it's a criminal offense not to protect personal data. So you need to have ways to protect the data. And even if you don't manage to protect sufficiently, you need to implement some kind of security, even if it's not sufficient, okay? When you handle them. And there is an organization in France that is responsible for this kind of protection, that is CNIL. And it's responsible to report all offenses to personal data protection. That's why credit card suppliers don't comply with French law too. So here is the timeline of the discovery. So I ordered my NFC credit card last November, and in only one day I was able to break all kinds of protection and gather all juicy information from the credit card. I notified my personal bank during the following week. They thanked me for this step, this help. Last January, Christine Paget's dad did something very similar and showed it at Shakacon, but he or she used, because he has changed his gender, she used a dedicated commercial reader, so she was more focused on the hardware than the protocol. Okay, she just put some commercial hardware and was able to extract information with this hardware. Here I show you how to gather all this kind of information with open source readers and only very cheap hardware. Last April, I notified some other banks, the French Ministry of Finance and the CNIL, during a short demo. A bit later, the organization responsible for the credit cards in France officially stated that they were aware with those kind of risk, but this issue was a laboratory experiment with theoretical risk. So this is what they say. I made a presentation at Akito at the Zoom last April too, and last week, it's very recent, my bank answered me that insurance will cover the fraud, but didn't answer anything about compliance. So yeah, I asked them about compliance. They don't have any answer yet. And currently, investigations are being made by some public organizations and law enforcement in France for this kind of offense. Yes, some legal context related to French law, because I don't want to get arrested, just exiting the room. This is not reverse engineering. EMV standard is completely open and public for a long time. The proof of concept is just a small EMV implementation. Okay, so no reverse engineering here. This is not made for counterfeit. because we have just extracted the personal information from the card. So this information, you have it already. You know your first name, your last name, your gender, your PAN, and the expiration date. It's all written on your card. There is no secret things I have extracted. And this kind of information is neither not necessary nor sufficient for counterfeits, because you don't have the technical information from the issuer, the bank, the keys, to do a counterfeit, practically. And we haven't broken any security because there is none. There is no authentication, there is no encryption, there is no digital signature, so there is no security. Thanks. So here you will find the Google Code project. I will release, as soon as I'm back to Paris, the Android version source code, so you can play with it. I encourage you to contribute if you have ideas and if you want to give a try to this application. Thank you for the staff, the Shakacon staff, who is really brilliant. And mahalo. Yeah.
I guess my big question is, can this be fixed? What the banks have told me is they know they're making this mistake. They know how insecure it is. They just want to get out there in the market, experiment with this technology, make mistakes, take the hit with fraud, and then fix it over time. So I guess my better question is, when we want to secure this system, are we going to have to rip a lot of things down to add security, or can we add security in an incremental fashion?
The problem is that it's not an implementation problem, it's a design problem. So you have to completely rewrite, redesign the protocol. You can't use EMV over contactless interface. EMV is not made for security and for wireless security. No encryption, no authentication.